Hello, this is Mr. Rivera, and I'm going to be talking you through some of the research methods, specifically looking at significance and errors. This is part of the A2 course, but it's also kind of leading up to the inferential statistics section where we kind of ask the question, kind of what do we actually do when we do research? So what I need you to think about is kind of how often do you perhaps use the word significant in terms of psychology, and perhaps in English you've used it quite a lot as well. And you're going to see that it's kind of used repeatedly in different ways. So in terms of English, you might have a significant other, or you might say, well, this particular grade is a significant grade because it was done under timed conditions or something like that. So we use significance quite a lot. So I'm going to talk through some of the significance that we talk about. And the first one is this one, pure statistical accident. Because what we're going to talk about is if I run a statistical test and I am going to try and work out whether the experiment that I ran actually was because of the data I collected or pure statistical accident. And so one of the ways we refer to significance is by using probability. Okay, so we're going to talk about the probability that my research has collected data that was pure statistical accident. Now you might ask, well, how can this be done? Well, it's down to this idea that when I run an experiment, all I'm really doing is collecting data. I'm not actually testing or proving anything. So I collect data, and data is usually in the form of numbers. Now, if any of you have ever messed around with calculators, some of them have random functions, or certainly a lot of computers do have a randomization feature. And I could potentially generate a set of numbers randomly as well. And so most of the statistical tests are ultimately going to be asking, are the numbers that have come from the experiment or the experimental data, could have they also just been generated randomly? And the answer is going to be, if the answer is yes, then it was pure statistical accident. And therefore, we're going to say it is not significant. If the answer is no, we're going to say, well, therefore my data is unique, and therefore it is significant. And so going back to probability, or P, we're saying, what is the probability that my data is down to pure statistical accident? So we often then quote your significance level in terms of a probability. And we see, for example, P is less than 0.05. So this is where we have to have some kind of maths, because we know that 5% is equal to 0.05 as a decimal. So what I'm ultimately saying is that we need to recognize that 1 is 100%. So when I quote something to be the probability is less than or equal to 5%. So in other words, I'm saying that I've got less than 5% that my data is pure statistical accident. It's quite good, because obviously that means that 95% of the data I'm quite confident is down to the experiment or the manipulation of the IV that has created the data. So we can talk about values of P being either high or low. Okay, so you could say that if I have a high P, high value of P, that could be something like 10%, and a low P could be 1%. Okay. Now what we see here is that a high value of P is actually less desirable, because that's saying that I only have 90% of my data, I'm sure, that is not down to statistical accident. And that's why when we talk about significance, we also have to talk about error. So the first thing we need to recognize is that we will have to ultimately decide whether something is significant or not. Before I do that, I need to state a level of significance. And so this is a level of significance. Okay, where I would state it like this: P is less than, I usually say less than and equal to 0.05, saying that I believe the probability of my data being pure statistical accident is 5%. And I also hope that you can see that 5% roughly sits somewhere in the middle. And that's why for psychology we use 5%. So what are these errors I'm talking about? Well, they're very, very unimaginative, and we see them as being type 1 and type 2 errors. Okay, they could have come up with better names. Okay, so a type 1 error, let's go back to this idea here of 10%, means that I kind of think that maybe 10% of my data is going to be down to pure statistical accident. So that's 10% being higher than 1%. And so what I'm ultimately allowing is more statistical accident to let in. And so what I can do is a false positive. Think about what false positive means. It's falsely positive. If I've let 10% of my data to kind of be excused, there's more chance that I'm going to get through the net, so to speak, and falsely say something is positive. So a type 1 error is when we ultimately decide that we have found significance. In other words, when I've run the data and I've compared my numbers with the theoretical mathematical numbers, I've said that there is enough difference in them that I'm going to say that the data that the test is significant. But the problem with it is I shouldn't have. And I should have actually kind of tested a bit more strictly. And so what we do when we have a false positive, it says we reject the null hypothesis when we should have retained it. So in other words, I've generated a hypothesis. I've said that I've now found significant data, and so therefore I accept my hypothesis and reject the null hypothesis. So it says here, for example, that this happens when we're too lenient. For example, P is less than or equal to 0.1 or 10%. It's kind of like if a doctor had a set of rules talking about pregnancy, and I went to the doctor and I said, look, I've put on a significant amount of weight, I'm a bit moody, often very tired, and you know, my breasts are tender. Okay, so kind of very kind of simple kind of diagnosis. They could look into their book and then come up with the diagnosis that you must be pregnant, because with the 10%, I've allowed things to not be there. For example, that I have to be female in order to be pregnant. Potentially, there are other kind of characteristics that we need to look at as well, whether kind of sexually active, whether I've had unprotected sex, whether like there's a whole host of different things that could potentially talk about that we should have included in my test. And so it's too lenient, and I've ultimately come up with a diagnosis that is false. And it's false positive because I've said you are pregnant. So that's significant. Yes, you've passed the test. You are pregnant. But of course, it's wrong. Maybe think about this in terms of some of the testing that happens for coronavirus and COVID-19, kind of have they had false positives and false negatives. And I certainly have people reporting to me potentially concerns about this. So if type 1 errors were because I was too lenient, well, we could completely go the opposite way and therefore make a type 2 error. And this is kind of where we're being too strict, and this is called a false negative. So in other words, negative means that I've found no significance. I've rejected, it says here, I've rejected the alternative hypothesis, but unfortunately I should have accepted it. So this often happens when we get to the 1% significant level, because what I've done is that I've made it so difficult to kind of to fail, so to speak, that you ultimately end up failing. So it's kind of like asking kind of too many questions, and therefore kind of making the decision that somebody perhaps is not managing to do it. So it's kind of like, I use another example in terms of sports teams. So for example, a type 1 error would be that I simply say, okay, so we have a fixture on Saturday. Anyone who's played hockey can play. I'm likely to kind of choose some people who are pretty rubbish and not make a good team. Equally, if I then say, okay, only people who have played at county level are allowed to kind of play, I might actually dismiss somebody who is very talented but hasn't played at county level. It's kind of, those are the type 1 and type 2 areas that we have. So I hope that kind of makes sense. There's a couple of exam questions. I mean, the great thing about these questions is that there's mark schemes and you literally just need to copy their answers because they give you an answer for it. So you could have something as simple as what is meant by type 1 error. So explaining a type 1 error, it's 2 marks. You can't just say it's a false negative, false positive, sorry. You have to explain it. This one was an interesting question because it says, what is the probability? So what is the likelihood that you've made a type 1 error? And so, of course, if my probability is 5%, then my answer is 5%. Because I'm basically saying I've got a 5% chance of things happening as they are. Now, I'm going to kind of stop there for now. I'm going to make a separate video for levels of measurement, and that should be fun.